Okay, I'm gonna do a few examples from week 3, radical equations that simplify to linear equations. That's one type. Um, let's look at, I want to go back up to, let's look at the square root of y plus 13 equals 8. Now to solve this one, I need to get y out from underneath that radical sign. So if we square both sides, we're going to get y plus 13 equals 64. Get y by itself, subtract 13 from both sides, so y equals 51. If I put 51 back into that original equation, I would get 64. The square root of 64 is 8. So yay, that checks. What if I have two radicals? So I have radical 7y minus 2 equals the square root of 4y plus 10. The same idea here. I still need to get that y out of the radical sign. So if I square both sides, I'm going to get rid of that radical sign and that radical sign. So now, like always, get everything with a y on one side of the equation. So subtract 4y from this side. So 3y equals, add 2 to both sides. 3y equals 12. Divide both sides by 3. So y must be 4. And I probably would want to check this in the original equation just to make sure. Here's another one. Square root of x plus 5 minus 1 equals 4. Okay, so this one, before I square, I've got to get the square root sign. I've got to get this by itself on one side of the equal sign. So let's add 1 to both sides. That's the very first step. So now I have x plus 5 square root equals 5. Now I can do what I did above by squaring. Then I get x plus 5 equals 25. So x must be 20. And again, double check to make sure that you're doing that right. Okay, let's do another one with 2 radicals. This one is 5x plus 16. Nope, sorry, that's a v. Minus the square root of 8v minus 14 equals 0. Now I don't want to square both sides until I can get the one radical sign on either side. So let's add this whole thing to both sides. So I got the square root of 5v plus 16 equals the square root of 8v minus 14. Now I can square both sides. And that's the first step. Make sure you got a radical equals a radical and nothing else to complicate things. So 5v plus 16 equals 8v minus 14. So get everything with a v on one side, everything without a v on the other side. So what we get a minus 3v equals minus 30. Divide both sides by negative 3. So v must be 10. Check it to make sure it works. Okay, so that's 2 radical signs. Now what if I have just one radical, 2u plus 3, but it's equal to a variable u. So now I have a u on both sides, and this u is underneath the radical sign, so I need to square both sides to get rid of it. So 2u plus 3 equals u squared. Now I'm going to have a quadratic. So I need to get it of the form ax squared plus bx plus c equals 0. That way I can either factor it or use the quadratic formula. So let's subtract 2u from both sides, subtract 3 from both sides. U squared minus 2u minus 3 equals 0. So there it is in the standard form of a quadratic equation. So now I can factor it to two binomials if I can. Two numbers multiplied together to give you -3, but added together to give you -2. And there they are. Those two factors multiplied together give me 0. So u is either 3 or u is -1 or both. But here's where you definitely have to check. So if I put a 3 back into the original equation, which was the square root of 2u plus 3 without squaring it, that would have been the square root of 6 plus 3. Is that equal to u, which is 3? Is that a true statement? So the square root of 9 is equal to 3. So that one checks. What about this one? If I put a -u back into the original equation, is 2 times -1 plus 1 equal to -1? Well, you are going to get the square root of 1 on this side, but that clue right there should tell you I can't take the square root of anything, of something, and get a negative number. So this one actually does not work. Now, what am I talking about there? Let me do another example. What if I had the fourth root of w equal to -2? So what that's saying is, what can I take the fourth root of and get -2? -2 to the fourth power equals what inside here? Well, just like that previous example, since this is a even root, there is no number that is that I can take the fourth root of and get negative. A while ago, it was the square root of something equals a -1. No, I can't do that because anything squared is going to be positive. Anything to the fourth is going to be positive. So the answer is empty set, which both of those are ways that you can represent an empty set. What about a cubed root, though? What if I have the cube root of x equals -5? So whatever x is, when I take the third root of it, I'm going to get -5. Can I do that? Yes, I can. So let's raise both sides to the third power. So x must be -125. And if the root is odd, then all I have to do is raise that to the next power. Okay, so there's some absolute value ones for you. No, the radical signs for you, sorry. Now let's look at some absolute values. The first type is 5y plus 10 equals 5. Now, remember what absolute value means. It means distance from zeros. It's going to be a positive number. So whatever 5y plus 10 is, after I take the absolute value of it, I'm going to get 5. So whatever 5y plus 10 is, it could be 5, or it could be -5, because the absolute value of -5 is also 5. So solve both of these. You're going to have two equations to get rid of the absolute values. So -10, -10. 5y equals -5, so y equals -1. -10, -10. 5y equals -15. Divide both sides by 5, you get -3. If I put -1 back into that equation, I would get -5 plus 10, which is 5. The absolute value of 5 is 5. Yay. If I put -3 in there, I get -15 plus 10, which is -5. The absolute value of -5 is 5. So they both check. So the answer, there's two answers. Y could be -1, Y could be -3. That's one type of absolute value. What if I have 5 times 2v equals 20? First thing I want to do is get the absolute value sign by itself. So we'll divide both sides by 5. So 2v absolute value equals 4. Now, once again, whatever's in the absolute value sign, 2v could either be 4 or 2v could be -4, because when I take the absolute value of it, that will make it positive. So divide both sides by 2. So v could either be 2 or v could be -2. Those are both correct answers. Okay, there's another one. Let's see. How about this one? What if I have absolute value of y minus 7 plus 28 equals 10? 28. Now I can't write it into two equations until I have the absolute value of whatever equals 8 from both sides. Subtract 28 from both sides. So the absolute value of y minus 7, we're saying, is equal to -28. Well, we can stop right there, because we know that if I take the absolute value of anything, I'm going to get a positive number. I'm not going to ever get -28. So there's my empty set again. This cannot be a true statement if that's my original problem. Okay. What about this one? 3 times 2x plus 5, absolute value, minus 41 equals -8. Now you might look at that -8 on the right-hand side and say, wait a minute, we can't do that because of what, like that problem we just did, but I need to get the absolute value by itself first. So I'm going to add 41 to both sides. Then I have 3 times the absolute value, 2x plus 5, equals 33. Now divide both sides by 3. So now I have an absolute value problem. The absolute value of 2x plus 5 equals 11. Now I can rewrite that as, well, 2x plus 5 is either 11. So -5 minus 5, 2x plus 5 equals 6. So x equals 3, or 2x plus 5 equals -11. So subtract 5 from both sides. So 2x equals -16. So divide both sides by 2, x equals -8. And if I check both of those in the original equation, I recommend that you do that to make sure that they both are true statements. So there's some absolute values for you. What about this one? This one's an easy one compared to those. So what this says is, whatever is in that equation, and I take the absolute value of it, I'm going to get 0. Well, I know there isn't such thing as a positive 0 and a negative 0. So this one is actually only going to have one answer. I can just get rid of the absolute value sign. So 2v equals negative 12. So what's going to give me a 0? Divide both sides by 2. V equals negative 6. Now, I need to check that back in the original equation. If I put a negative 6 and multiply it by 2, I get a negative 12. Negative 12 plus 12 is 0. So it checks. So there's another type of absolute value problem for you. Hopefully that'll give you a little bit more practice looking at radical equations and absolute value equations for week 3. Hopefully you're working on your homework or you're almost done with it. I will do some linear inequalities and absolute value inequalities in the next day or two. That will get you ready for week 4, and that will cover all the material that we were supposed to cover for the first exam. So you'll be able to do an exam towards the end of the week, next week. So the exam will be due the 28th. Today's the 21st, so you've got to finish homework for tonight, and then you'll have homework for the week of the 28th, due the 28th, and you'll have a test at the end of next week also. So I'll make this available, and then you can practice.